For those of you that have watched my channel before, you know that I take my little Jack Russell Terrier, Shadow, to remote, dark, high elevation places to do astrophotography, where the seeing conditions are more ideal for capturing deep space objects such as nebulae, distant galaxies, and so forth. On the night of February 19th, 2023, we were doing just that from the northeastern edge of the Mojave Desert in what is known as the Beaver Dam National Conservation Area. Well, all things went according to plan, and that was a single frame image of the Orion Nebula, the Running Man Nebula, the Head Nebula, and the Flame Nebula, all in one field of view. Now, in astrophotography, the more time you can get on an image, the better. You want to capture as many of those distant photons as you can. So let's say you're going after a 60-minute exposure time. Well, you could do that in one 60-minute photograph, or you could do it in 61-minute photographs and stack them, or 120 30-minute photographs and stack them. I tend to go with shorter sub-exposures and stack for a number of reasons, one of which is going to show when I show you the footage as to why I like to do that. Because there's a lot of satellites and airplanes up there, and when they cross your field of view, they leave a streak. And if you're just doing one really long exposure, well, it can really mess up your imaging session. But if you're doing multiple shorter ones, then when a satellite crosses, you can just discard that one and use the others, and you end up discarding a fair amount these days. Well, on this particular night, everything went fine. I was very pleased. The following day, when I was processing the image, I had 605 frames, and I looked through each one of them briefly. It doesn't take long to see a ugly old streak through them, and you throw them out and don't use it. I noticed, however, a series of very light, faint streaks, and I'm going to show them to you in a minute. They were so light that they averaged out, and they were in almost every frame, but they averaged out, so it didn't interfere with the quality of the overall image. And I went ahead and I made a video. It wasn't until after I actually posted that on YouTube that I got curious about these little streaks. And so I went back and I looked at them. I made the conclusion that they must be StarLink satellites. You hear about those all the time. StarLink launches a series of satellites, and they're like a streak, like a caterpillar across the sky. And people photograph them with just ordinary cameras. When you look at the video footage that people have taken with just a regular camera, they're moving across the sky at a relatively rapid pace. But what I captured was very slow. So I took the 605 frames in a video format and emailed it to a friend of mine who's far more advanced in astrophotography than I am. Tim, if you're watching, hi Tim. And he got back with me and he said, I think it's StarLink. So I left it at that. But then it kept weighing on me. And I sat down, put some pen to paper, pencil to paper, because there was a lot of erasing, and did some mathematics that I'm going to share with you. And I've come to the conclusion, this is my personal opinion, I'm not a mathematical genius or a physicist or an aeronautical engineer. I'm just an amateur astrophotographer, and I had to kind of just do some basic math. But I'm going to share that with you. And then I'm going to ask you, did I indeed capture a series of UFOs? I'm hoping that one of you can help this dummy be just a little less dumb by showing me, where my math might be wrong, or providing the simple explanation of what it is that I captured. So let's start by viewing the video first. What you see on the screen right now is one, and the first one, of 605 individual images or pictures that I took that evening of the Orion Nebula on the right and the Head Nebula on the left. I'm going to zoom in onto the Orion Nebula. Now I'm zooming in onto the Orion Nebula, and I want you to pay attention to the lowest big bright star on the lower right hand side of the nebula. And you'll see these little dashes coming down from the top of the right of the screen and going right through that star, actually in front of that star, one after another. And here's another one coming down. Can you see those? Now, those are each little dash is the next frame. I'm just playing them one after another, after another, after another. So you're seeing how far they move in the time that it took to take that frame, which was 10.6 seconds. So here comes some more. Every 10.6 seconds, they move a little further. You see that? Now, you're also seeing some fast streaking lines through the image. Those would be your typical satellites. They fly through the screen. There went one right there. They fly across the field of view rapidly. But then you've got all these little ones that are very slow in comparison to the other streaks or satellites. Now I'm zooming out here to show you the full field of view so that you can see that you don't really see these little moving objects anywhere else, just along that one spot. Now, there are a few that crossed over just to the left of the Orion Nebula, but there's some more right there. You see them to the right-hand side there of the nebula. Now, that fast one there is more typical of a faster-moving satellite, but this little corridor where they keep coming across, there's another one, and there's one, an anomaly, a one-off on the far left. But most of them pretty much stay in that corridor from the upper right hand down along the right edge of the Orion Nebula. Here's some more coming. Now, I've counted multiple times and I come up with a little bit of a different number each time because they're kind of hard to see, but there's another one coming. The last count was 40, so I'm going to go with that. However, I only took 605 images. What if I had taken 700, 800? And how many are there? And at the speed they're moving, there's no way they could have gone all the way in orbit around the Earth and then crossing through my field of view again. We're going to show some of the mathematics of why I don't believe these can be StarLink satellites. That will come later. Right now, I just want you to see them. And I'm zoomed out a bit here again so that you again can see that that's pretty much where they hang out on that right-hand side. Let me just zoom in again. There you go. 1, 2, and there'll be more. So the most important thing I need you to keep in mind when we move into the next phase of this video is you've seen them. There's another one. That each individual picture is an 11-second exposure, so you can see how far they move in 11 seconds. And I've also counted about how long does it take for one to cross the diameter of the Orion Nebula, you know, the equivalent of the diameter. And it's about 15 exposures. It takes about 15 exposures for them to cross all the way through. That will come into play in the math I'm going to show you here momentarily. For this next part of the video, I'm going to go over some basic math that I've put on some poster boards. My handwriting isn't great. I didn't try to even make it pretty. I just want to illustrate why I've concluded that what you just saw can't be StarLink satellites, and quite possibly can't be explained as any satellite in a low Earth orbit. So let's jump into the math. We know that the circumference of the Earth is 24,901 miles. We know the radius of the Earth is 3,900, and it's actually 58.8. I'm going to round it to 3,959. The circumference equation, the circumference of a circle, is calculated by 2 times pi times the radius. 2 times pi, which is 3.14 and on into infinity, but 3.14 times 3,959 miles, and we get 24,862. Or, because I used a rounded number, it's very close to 24,901. StarLink satellites, they orbit in what's called a low Earth orbit at an altitude of 342 miles above the Earth. Now, they can move some, but they are in low Earth orbit. What is the circumference of the StarLink orbit? Well, we know what this radius is from here to here. We can add 342 and we can come up with 4,301. The circumference of the StarLink orbit is 2 times pi times 4,301, or 27,010 miles. StarLink satellites travel at approximately 18,000 miles per hour. And that allows them to completely circle the Earth every 90 minutes. So how long does it take StarLink to pass through 1 angular degree? Well, if we use the center of the Earth and we divide into 360 degrees, then we can take the 90 minutes that it takes to circle the Earth, divide it by 360, and we get 0.25, or 25% of a minute. There are 60 seconds in a minute. That would be 15 seconds. So it takes StarLink 15 seconds to pass through 1 degree. Now, the important thing to remember is that is assuming the center of the Earth is the viewpoint. The center of the Earth is where the lines originate to divide the 360 degrees. Now, when Shadow and I were in the Mojave Desert, we weren't in the center of the Earth, we were on the surface. So, from the surface of the Earth, when we're looking out, if you were to divide our point of view, as we did a 360, into 360 degrees, you see it's going to be narrower at where StarLink orbits than the 1 degree that originates from the center of the Earth. So if it takes 15 seconds for StarLink to cross 1 degree that originates from the center of the Earth, how long would it take for StarLink to cross 1 degree from our perspective? Well, we do the same thing. We know the distance of StarLink from me and Shadow is the orbit altitude of 342 miles. Thus, from our point of view, the radius is 342. Therefore, the circumference around us would be 2 times 3.14 pi times 342 equals 2,148 miles. So our circumference, which would intersect with where StarLink passes through our degree is 2,148 miles. So how wide is it right here for one of our degrees? Well, it would be the circumference, 2,148 divided by 360 degrees, or 5.96 miles. Now, using the center of the Earth, the circumference is 27,010 miles divided by 360 degrees, and you end up with 75 miles to a degree. So the ratio of my degree to a degree from the center of the Earth minus 5.96 miles across, the center of the Earth is 75 miles, so it's 0.079. My degree is 0.079, 7.9% of what a degree would be being measured from the center of the Earth. So how fast does StarLink pass through 1 degree from my viewpoint? When it's coming along through here, well, it is 7.9% of the 15 seconds it takes to cross 1 degree here, and that comes to 1.19 seconds. I'm going to round it to 1.2 seconds to pass through one of my degrees. This is why this is so important. So here I am, Shadow and I, on the surface of the Earth again. We walked over here. We're going to measure from here. If we were to divide our 360 point of view into 360 degrees, we would start with 0 degrees. I'm doing this in increments of 10 degrees, 10 degrees, 20 degrees, blah, 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 130 degrees, 140 degrees, up to 180 degrees, and so forth if we continue to round. This is the Orion Nebula, and it's really, really big, and it is 1,344 light years away from our telescope. So as this 1 degree extends and extends and extends and on and on and on, it gets wider and wider. The Orion Nebula fills approximately 1 degree. Interestingly, the moon fills 32 minutes, and there's 60 minutes in a degree, so roughly 1/2 of a degree. And the moon is 238,900 miles from my telescope. The sun comprises 52 minutes, or almost 1 full degree, 52/60ths of a degree. It's 93 million miles from Earth, or 8.6 light minutes. The Orion Nebula is 1,344 light years, or 82 million times further away than our sun. So it's very distant, and it's huge. It fills 1 full degree. It is 24 light years in diameter. So we call its angular size 1 degree. This poster illustrates why the UFOs could not be StarLink or any other satellites, for that matter, in low Earth orbit. If you look at the writing in red at the bottom, we know that StarLink passes through my 1 degree in 1.19 seconds, and my 1 degree is 5.96 miles across, where StarLink would pass through my 1 degree, meaning the degree measured from my standing on the surface of the Earth. So if StarLink were to cross my 5.96 mile, where it crosses over my 1 degree in 1.19 seconds, well, that would be a speed of 5 miles a second, or 18,000 miles per hour. And that is what StarLink travels at. So if we use the same formulation now with the UFOs, and we say the UFOs, they pass through my 1 degree in 159 seconds. Well, 5.96 miles divided by 159 seconds That equals 0.0375 miles a second, or 134 miles per hour. 134 miles per hour is far, far too slow to hold Earth orbit. They would be falling like stones. I think we can rule out that these UFOs were StarLink or any other satellites in low Earth orbit. There's just no way it could make sense for them to be StarLink if they're crossing my 1 degree in 2 minutes and 39 seconds. They'd have to be in much higher altitude orbit, but I'm not aware of any satellites that are in series like that. I counted 40 of them, one after another, that are in high Earth orbit. Those kind of satellites tend to be your stationary geosatellites around the equator. I don't think there's anything like 40 of them in a row, one after another up there. So my question to you is, what are these things? I'm sure there's a logical explanation. Can you help me out? Shadow and I really don't want Will Smith knocking on our door. I look forward to your comments. Thanks a lot.